9.2 is measures of variation, and it starts with a whole bunch of definitions. Range, I think you already know that, is the difference between the largest and the smallest numbers. Standard deviation and variance is kind of a bigger deal. Standard deviation is the square root of the variance, a measure of variation from the mean. So we're talking about how much numbers vary from the mean. But one thing you'll need to know is standard deviation is the square root of the variance. That comes up every now and again, but variance and standard deviation are very closely related. They're both talking about numbers and how they vary from the mean. Variance is the mean of the squared deviations from the mean divided by n minus 1, denoted as s to the second power. Sample variance. Sample variance is the variance of a random sample. That's what we will be calculating, s squared. Sample standard deviation. Well, if standard deviation is the square root of the variance, then the standard deviation is just going to have a symbol of s. Population variance, population standard deviation, those are a little bit harder to calculate because there's so many more people, but variance of population symbol is sigma squared, and so the square root of that gives me the standard deviation, sigma. Measures of variation show how much numbers in a sample vary from the mean. Example 0 says compare how each numbers in each data set vary from the mean. You're going to have to be able to calculate the mean, and if we look at the mean of this data set, you add those up, that's 8, 14, 17, 20. That's 20 divided by 5 is 4. And clearly, if I take the mean of this, it's going to be the same thing. It's going to be 20 divided by 5 is 4. And what you're supposed to notice is the numbers in the second data set don't vary at all from the mean. As opposed to the numbers in the first data set that do vary from the mean. None of them are equal to 4. There's a 5, there's some 3s, there's some 6. But they're pretty close. They're pretty close. Look at the last data set, the third data set. 10 plus 1 plus 9, that's 20 over 5. The mean of these numbers is 4. But you're supposed to notice that these numbers vary a lot more from the mean. They're different from the mean. So we'll say they vary widely from the mean. And the numbers in that first set vary a little from the mean. Where standard deviation and variance come in is it's going to put a number on that, okay? It varies a little bit from the mean, or it varies a lot from the mean is kind of subjective, right? So we're going to use those calculations, the standard deviation and the variance, to put a number on that so we can compare. Example 1 says find the range. All you have to do is max minus min. That should be pretty simple. So 42 looks like the max in this set of numbers, and 6 looks like the min for this set of numbers. So all it is 42 minus 6 is 36. That's the range. So that's one of the easier calculations you've got. Next one, 200 is the max. 59 is the min. Big minus little, 141. Number 2, it says find the deviations from the mean and the mean of the deviations for 32, 41, 47, 53, and 57. So that's a little bit weird because it's not talking about variation and it's not talking about standard deviation. It's kind of getting our feet wet, I suppose. Deviations from the mean. Well, in order to find the deviations from the mean, we would first need to find the mean. mean, x bar. We add up those numbers, add them up, and it looks like we're going to divide by 5, right? That's how you find the mean. Add the numbers and divide by the number of numbers. Well, when I added those numbers, I got 230. And we're going to divide by 5. We get 46. So this question is asking me how much do each of those numbers deviate from 46? Let's look at it like this. First number is 32. If you subtract 46, that's a difference of negative 14. 41, if you subtract the mean, that's a difference of negative 5. We're talking about it's 14 below the mean. It's 5 below the mean. That third number, 47, is 1 above the mean. The next number, 53, is 7 above the mean. And 57 is 11 above the mean. So when it says find the deviations, those would be the deviations. Those would be the deviations. But then in parentheses, it says find the mean of the deviations. So if I wanted to find the mean of the deviations, add up those numbers and divide by 5. Well, when I add up those numbers, negative 14 plus negative 5 plus 1 plus 7 plus 11, that adds up to 0. And so the mean of the deviations would be 0 divided by 5 is 0. It turns out that would always be 0. That's kind of a weird question to ask. That's always going to be 0. If you think about it, the mean, you don't really want to say it's the middle, but it's like the average. And so, some of them are going to be below and some of them are going to be above. And when you average that out, you get back to the mean. And so it kind of makes sense that mean of that deviations is 0. The sum of those deviations always equals 0. So the mean of the deviations will 2. That would always be 0. This isn't really a good representation of variation. If that's always going to equal 0, that's not a very good method for talking about that variation or that deviation or whatever. And so what we're going to do to get around this, we could square the deviations. And that's a weird thing to talk about, but I'm trying to lead you into the equation for variance and the equation for standard deviation, because it seems like there's this big complicated formula, but this is what we're trying to get at. Something like negative 14 squared plus negative 5 squared plus 1 squared plus 7 squared plus 11 squared, something to that effect, would keep the negatives from canceling out the positives and getting us to 0 every single time. Something like that. We have two different formulas for variance. Remember, for a sample, that's S squared. And capital sigma means sum, so we're going to have to add some things together. That's what we do when we find the mean anyway. We add up the numbers or whatever. But that's capital sigma. That means sum of x minus x bar squared. When I say x in this formula, x is just each individual number. Each of those numbers, like, what were they, 32 and 41 and 47, those are your x numbers. And then x bar is the mean. And so you're going to subtract those. You're going to square that. And then you're going to divide by n minus 1. And so that's kind of similar to what we did before. We subtracted those values and we got those numbers. We took an x value. We took an x value minus the mean, which was each of those numbers, and then we're going to square those numbers. and then we're going to find the sum of that. So that's kind of where we're at here. Dividing by n minus 1 is a little bit weird, but that's just what this formula says. There's a reason why, and that'll be covered later, but this is your formula for variance. Then they give us something they call a shortcut. It doesn't look like a shortcut, but it's just a little bit easier to calculate this way. S squared equals sigma x squared. So that's you take each individual number and square it, and then take the sum of that, minus n, which is the number of numbers, times x bar is the mean, squared, and divide that by n minus 1. That formula looks nuts, it looks crazy, I get it, but that's where it comes from, is kind of doing what we're doing here. We're talking about how much those numbers vary from the mean, and we're trying to get some kind of a value to put a quantity on that. Standard deviation. Now remember, standard deviation is the square root of the variance. We already talked about that. So all we have to do is take that variance equation, and we want the square root of that. Standard deviation is S. It's going to equal the square root. And I'm just going to copy my shortcut formula. Sigma x squared minus n x bar squared over n minus 1. Standard deviation is the square root of the variance. Now that's standard deviation of a sample. Sample is just if I picked 30 people to represent the entire school. Finding the population is a lot harder. Number 3, we're going to find the standard deviation of the numbers 7, 9, 18, 22, 27, 29, 32, and 40. I'm going to start by just writing down my equation again so I can remember what I have to find. N in this formula is the easiest thing to find because n is just the number of numbers, and we can look over there and see that there are 8. There are 8 numbers in that list, so n is 8. X bar is the mean of those numbers, so we know how to do that. We're going to add them up and divide by 8. We add those numbers up, add those together, plus, we get 184. But to find that mean, we're going to divide by the number of numbers. 184 divided by 8 is 23. So what I'm doing here is I'm looking at the equation for standard deviation, and I'm just trying to build out what I need to build out. I know I'm going to need an n. I know I'm going to need the mean, x bar. And then when it says sigma x squared, I have to add up all of the values that have been squared. So I think it makes a lot of sense to come over here, and if these are all my x numbers, then think about x squared. X squared. Well, 7 squared is 49. 9 squared is 81. And 18 squared is 324. And 22 squared is 484. I already did these calculations ahead of time. 27 squared, 27 times 27 is 729. 29 squared is 841. 32 squared is 1024. And 40 squared is 1600. So for this formula to work, you're going to need to find the sum of all of those x squared values. the sum of all of those x squared values, 49 plus 81 plus 324 plus. So I got to add all those numbers together. You guys understand that? That's what I'm doing. Once I added all those numbers together, I got 5132. So at that point, I can start plugging into my equation. S equals the square root. Sigma x squared is that 5132 minus n is 8. X bar was 23, but I'm going to need to square it according to this formula. X bar squared. And then I'm going to divide by n minus 1. Well, if n is 8, then n minus 1 is going to be 7. You can plug that into your calculators. And we're going to get about the square root of 128.57. Square root of 128.57 is about 11.3. So find the standard deviation. We're going to call the standard deviation 11.3. Now, most of your calculators have functions that will do standard deviation for you. And you can look at it on your calculator. On this one, you can just do STD for standard deviation and just list the numbers. 7, 9, 18, 22, 27, 29, 32, 40. There it is right there, 11.3. 11.3. And so you're left with the thought of, why in the world did we have to calculate all that by hand using that formula? And the answer to that is, I suppose, because it's fun, right? Wasn't that fun? Yeah? All right. Notice we can also do variance. Oh, maybe not. Variance? Yeah, variance. But remember, the standard deviation is the square root of the variance, so we could just have taken this and squared it. That's your variance. I think we can also do mean. Again, most of your calculators will do that stuff for you, like single variable statistics. So I think it helps to know how your calculator works, whichever one you're using. But that's standard deviation. Standard deviation is a number, and it's talking about how much those numbers vary from the mean. It's kind of a number that's trying to pinpoint how much the numbers vary from the mean. If the standard deviation was 0, that means those numbers don't vary at all from the mean. I suppose we could check that out. If I did, let's do this. Standard deviation. That's standard deviation. Standard deviation should be 0. And that makes sense because those numbers don't deviate away from the mean at all. So the bigger the standard deviation means the more those numbers vary away from the mean. Interpreting standard deviation, most data are within 3 standard deviations of the mean. That's gonna come up big in the next lesson. Complete the number line to show this fact using X bar and S from example 3. What was X bar? 23. X bar was 23 and S was 11.3. So what this says, X bar is 23, but X bar plus S is 34.3. and X bar plus 2 standard deviations is 45.6. And X bar plus 3 standard deviations is 56.9. X bar minus S, 11.7. X bar minus 2S, 0.4. And X bar minus 3S, negative 10.9. What this is saying is, if you look at this range right here, they're saying that most of the data are supposed to be, or are going to lie within 3 standard deviations of the mean. Most data in this case are going to be within negative 10.9 to 56.9. It's going to be in between those two numbers, most of the data. So we'll go back and look at the data. This was just a sample. So, like, take a population. I don't have all of the numbers. I just have a sample of the population. All of the numbers. There's going to be, hundreds or thousands or whatever, however many numbers there are. What this is saying is that we know that most of the data are going to be in between negative 10.9 and 56.9. Sample versus population. Sample variance S squared approximates the population variance sigma squared. Sample standard deviation S approximates the population standard deviation sigma. Next, we're going to talk about standard deviation for grouped data. I had showed you a shortcut that your calculator will handle. Unfortunately, your calculator won't give you that same shortcut for the grouped data. You can see an example of grouped data here. It's that frequency table. You've got numbers in between 0 and 4, and there are 3 of them. That's what they're talking about when they say grouped data. S, the standard deviation, equals the square root of sigma fx squared minus n times x bar squared over n minus 1. It's not hard to calculate. It just takes a little bit of time to build it out. We're going to do that in example 4. Find the standard deviation for the grouped data. This came from last section. Interval 0 to 4, frequency 3, interval 5 to 9, frequency 4. You can see that just means that there's 4 numbers between 5 and 9. The easiest part of this equation to find is n, because all you have to do is add up these number of numbers. There are 3 numbers, 4 numbers, 6 numbers, 8 numbers, 5 numbers, 3 numbers, 1 number. That adds up to 30. So n equals 30. There are 30 total numbers. When you look at the formula, we're going to have to sigma fx squared. So we're going to have to add up f times x squared. Well, what's x? X is the midpoint. And so you got to look at this interval and say, well, the midpoint of that is 2. So we're going to call x. Let's build out the table with more columns. X is the midpoint of the interval. So the midpoint is 2, and this midpoint is 7, and this midpoint is 12, 17, 22, 27, 32. But I need x squared, and so I'm going to need to square all of those numbers right there. 2 squared is 4, 7 squared is 49. I'm just squaring all of my x column. 12 squared, 17 squared is 289. 22 squared is 484. 27 squared is 729. 32 squared is 1024. But the formula says we're going to take the sum, we're going to take the sigma of f times x squared. Well, this is f, and this is x squared. So we're going to need to multiply f times x squared. So new column, fx squared. If I multiply those two numbers, 3 times 4 is 12. Everybody see where that came from? F times x squared, 3 times 4. 4 times 49 is 196. These numbers are going to get kind of big. Six times 144 is 864. 8 times 289 is 2312. 5 times 484 is 2420. 3 times 729 is 2187. And 1 times 1024 is 1024. Can anybody guess what I'm about to do? Since my formula calls for the sigma, I'm just going to add up those fx squareds. Sigma fx squared is that sum. I'm going to sum those numbers, 12 plus 196 plus 864, and I get 9,015. Okay, so if you look at your formula says S equals the square root of sigma fx squared. That's going to be 9,015 right there. Minus n we said was 30 times x bar squared. We don't know that one yet. X bar is the mean. Over n minus 1, well, n was 30, so that's going to be 29. We almost have all of our formula filled in. We're going to need that x bar. X bar. This is the mean, and you know how to find the mean is you add them all up and you divide by the number of numbers. Well, you add what? Well, we're adding x. So we got to do, basically we need to do sigma x divided by n. That's the formula for mean. Add them all up and divide by the number of numbers. So, like, I guess I wrote this formula down wrong. We're not actually adding up the x numbers because, as you'll recall, like this midpoint was 2, but there were 3 of them. So I guess what I should have said is we're going to add up f times x, because there are 3 of these numbers and there are 4 of these numbers, so it really needs to be the mean of f times x. Are we good there? I know I kind of misled you there for a second. So we need we actually need another column because we haven't done f times x yet. F times x, let's do it over here. 3 times 2 is 6, and 4 times 7 is 28, and 6 times 12 is 72, 8 times 17 is 136, 5 times 22 is 110, 3 times 27 is 81, and 1 times 32 is 32. We got to find that sigma. That adds up to 465. Okay, so all that said, we're finding the mean of those x values. It's not just this x value, it's this many of those x values. It's going to be 465 divided by 30 numbers. 465 divided by 30 numbers is 15.5. Which goes right here, 15.5. That's our mean. That's the mean. And the rest of this is just a calculator question. We can do that square root. So we should be able to type that in. Square root of fraction 9,015 minus 30 times 15.5 squared divided by 29. No, 7.89. 7.89. S, the standard deviation, is about 7.89. Questions on that? I wish there was a shortcut, but I don't believe there is. You're just going to have to do that. You're going to have to build out that table and fill in that formula. Number 5 looks a lot harder than it actually is. In what percent of contests did the number of hot dogs eaten by the winner fall within 1 standard deviation of the mean number of hot dogs within 2 standard deviations? Okay, so we need the mean and the standard deviation. And this is not grouped data, so this is one where you can just take these numbers. You should be able to use your calculator and find the mean, find the standard deviation. The easiest thing is just type them all in. On your TI, you're going to type them into a list, and you can do your 1 var stats. I went ahead and did this already. I got 45.51 for the mean and 16.57 for the standard deviation. When you do your 1 var stats on the TI, make sure you find the one that says S, because it'll give you S, X, and it'll give you sigma X, lowercase sigma X. S is for the sample. That's what we want here. So the question says, the first question says, what percent fall within 1 standard deviation? So what that means, well, for 1 standard deviation, I'm talking about from X bar minus S to X bar plus S. That's 1 standard deviation. You subtract it, you add it. And so 45.51 minus 16.57 is 28.94. And 45.51 plus 16.57 is 62.08. I could reword the question to say, what percent of the contest did the number of hot dogs eaten fall between 28.94 and 62.08? That's an easier way to understand the question. Look at the numbers, okay? How many of them are between? Well, let's see. This one's not in between. This one's not in between. Not. This one is, this one is, this one is, this one is. This one is, this one is. These are all in between those numbers. 66, that's not between. 59 is. 68 is not. 54 is. And so you can just count here. Count the check marks. 1, 2, 3, 4, 5, 6, 7, 8 check marks. It's 8 out of 2, 4, 6, 8, 10, 12, 14 numbers. That's the fraction. That fraction was in between. That's about 0.57. So we can say 57%. 57% of those numbers fall in between 28.94 to 62.08, or in other words, within 1 standard deviation away from the mean. But then it asks about within 2 standard deviations. So it's It's a similar question, but this time it's within 2 standard deviations. So in other words, x bar minus 2s to x bar plus 2s. I want to be within 2 standard deviations away from the mean. And all you're going to do is 45.51 minus 2 times 16.57 and 45.51 plus 2 times 16.57. Simple calculation. I'm going to give you this range of 12.37 to 78.65. So the question is really how many of those numbers, what percent of those numbers are in between 12 and 78, basically. And you look at it and you look again and you're like, well, aren't all of them in between there? Aren't all 14 of them in between 12.37 and 78.65? So it's 100%. The answer to that question is 100%. 100% of these numbers in this table fall within 2 standard deviations away from the mean. Now, there is one last thing that I have to talk about because it's in the homework and I didn't leave room for it. So there's a little bitty margin at the bottom. You're going to try to squeeze it in there. It's something called Chebyshev's theorem. Chebyshev's theorem. And it kind of deals with these probabilities. It's going to give us the probability of being within K standard deviations from the mean. Okay, there's more, but let's just get that. Probability of being within K standard deviations from the mean is at least (1 minus 1 over K squared). Side note, K must be greater than 1. So I've got a little bit of room right here. I'm going to do one example, okay? If I want to be within 2 standard deviations, okay? Chebyshev's theorem is going to give me that probability of being within 2 standard deviations away from the mean. I'm going to say 1 minus 1 over K is 2. K is that number of standard deviations squared. That's 1 minus 1/4, which is 3/4, or 75%, 0.75. So it's talking about that probability. The probability of being within 2 standard deviations is at least 0.75.